All right, this time let's do the Desmos Unit 8, Lesson 2 practice. So first we got a warm up. It says order these probabilities from least to greatest. So remember, probabilities can be represented as fractions, decimals, and percents. The closer you are to 0, the lower the probability, and the closer you are to 1, the higher the probability. And that's it. All probabilities are between 0 and 1, or 0% and 100%. So let's see here. We got 60%. We got 8 out of 10, 8 tenths. That's the same as 80 out of 100, so 80%. 60%, 80%, 0.37, aka 37%, 20%, and 5/6, which I believe if you got these memorized now, or if you punch that into a calculator, let's hear, what are you going to get? Is that more or less than 80%? Because that's the highest one we got right now, and it's going to be up in that neighborhood. Let's see here. We want to turn that 5/6 into a percent, so it's easier to compare to all the other ones. Let's do 5 divided by 6. 0.83 repeating. Now to turn that into a percent, we would move that decimal point 2 spaces behind the 8 and then behind the first 3. So we get 83.3 repeating percent. So that's the highest one, right? The next highest was 80. So highest. I gotta get rid of this brown marker. I tried to use that on the last video and that didn't work very well. So 5/6 will go here in the greatest spot. I think the next one down was the 80%. That's the 8 out of 10. So it'll go here. Oop, I almost went too far. I had to turn around. Then the next one after that was 60%. So it'll go here. And then the next biggest one from there was the 37%, and the smallest one was the 20%. All right. Next, it says list the sample space for each chance experiment. The sample space is a list or diagram or a table or something that shows every single possible outcome from a chance experiment. Why is it called a sample space? That's kind of a technical thing that would be hard to explain, but one way you could think about it is when you list everything out, you take up space, right? Take up space on your paper. And then every time you conduct the chance experiment, you're going to get one of those outcomes that you listed, and it's almost like you're taking a sample from it. Like, oh, I'm picking this one. Oh, I'm picking this one, just by flipping a coin or rolling a die. And so it's like you're taking samples from the space you used to write this list. That would be my 7th grade version of explaining why it's called a sample space. So what's the chance experiment? I lost it. Where are we at? Oh, we got different ones. Okay. Selecting a random season of the year. So if I put the seasons of the year like on different pieces of paper and put them in a hat, and I told you to pull one out, what are the 4 things you could get? It's essentially just the 4 seasons, right? So you need to write the 4 seasons. We could like abbreviate though. I'm okay with abbreviations when you're having to do this sample space writing stuff because it could be kind of tedious. So how about we can go SP for spring. I don't want to just use S because we got summer to think about too, right? So spring, SU for summer, W for winter, and F for fall, or A for autumn, if you prefer to call it autumn. I use F for fall. There you go. There's your sample space, the 4 things you could possibly get if you were choosing a random season. Now, the sample space isn't 4. Don't write the number 4. You could say the size or the cardinality, if you want to use a fancy word, of the sample space is 4 because there's 4 things in it. But the sample space itself isn't the number 4. It's the list of the things. Okay, so selecting a random day of the week. If you list all the days of the week and then pick one at random, that's your sample space. So you got your Monday, your Tuesday, your Wednesday, your Thursday, your Friday, your Saturday, and your Sunday. That's your sample space for selecting a random day of the week. All right, and the last one, selecting a random block out of a bag with 2 green and 3 blue. Okay, it says you're only selecting 1 random block though. So the only two outcomes you could get is either a green or a blue. Like you don't have to think about this one any further because it's not because it's only one block. So you don't have to think about combinations like, oh, you could get a green or a blue, or oh, there's a better chance of getting a blue than there is a green because there's more blue. All those things are true, but your sample space, the possible outcomes is just a green or a blue. Whichever one's more likely or whatever doesn't really change how you write your sample space. It would change how you use it, now you think about it. It doesn't change much on how you write it. Okay, let's move on. It says estimate or calculate the probability of each event. Well, which one do you want us to do? You want us to estimate or calculate? Those are different things. I don't like kind of weird directions like that, but okay. Use the probability scale if it helps you with your thinking. So they're talking about this scale down here when they say that. It's just some words that can help you think about how the numbers and probabilities work. So if you say something has a probability of 0, you are saying it's literally impossible. It is absolutely impossible that that thing could happen. And if you say it has a probability of 1, then you're saying it's certain, meaning there's no possible chance that the thing could not happen. If you say a half or 50-50, 50% or whatever, then you're saying it could go either way. There's an equal chance that it does happen or does not happen. If you're saying about here, where this would be about a fourth or 25%, 1/4, then you're saying it's unlikely, but there's still a chance, right? And then if you go here between a half and 1, around 3/4, then you're saying it's likely. It's probably going to happen, but there's still a chance it might not. Okay, so what's the probability that we read this sentence? Well, we just did, right? Or at least I did. Hopefully you're reading along. So I guess that means it's certain, right? It happened. So the probability of that is a 1. A fair coin lands on heads when flipped. Okay, and now I know we could talk about there's a probability it lands on its edge or leans up against something. Generally speaking, when we do this probability work, at least in 7th grade, we don't think about what we would call fringe outcomes like that. And so I think the idea here is that it would be 50-50 or 1/2 probability that it's going to land on heads. A weekend day is selected randomly from the days of the week. So we got our sample space here, right? Now, if you want to know the probability of selecting a weekend day from this sample space, count the weekend days. You got your Saturday and your Sunday. That's 2. Out of how many days are there possible? 1, 2, 3, 4, 5, 6, 7. So it's a 2/7 probability of getting a weekend day. Let's see here. 2.4. You see a live unicorn outside today. Now, we could talk about the possibility that unicorns exist and we just haven't seen them, or unicorns will magically appear today or something. But for me, I am confident enough to say that it is impossible that I will see a live unicorn outside today. And so I will go 0 probability on the unicorn sighting for today. 2.5, a spinner with equal parts red, yellow, and green. So it's talking about one of these things, like I have at my desk. Equal parts red, yellow, and green. So 3 parts. That looks like this. And you got, I could use colors, but I'm lazy. You got red, yellow, and green, and then you spin, you flick it and spin the little thing. The probability that it lands on green. Well, the different sizes, the areas are the same size, right? There's the same space for red, yellow, and green. So we would call that fair. So green is 1 outcome out of 3 equally likely possible outcomes. So 1 out of 3, 1/3. And 2.6. You pick a green block when you randomly pick 1 block from a bag with 7 green blocks and 3 blue blocks. Okay, so green is 1 possible outcome out of the 2 possible outcomes. But in this case, the 2 possible outcomes are not equally likely. So we have to think about this a little bit while we're doing it. There's essentially 7 green possible outcomes because there's 7 green blocks out of a total of 10 blocks total because there's 7 green and 3 blue. So I would say you got a 7 out of 10 chance of pulling that green. Okay. We're moving down here to where it says a computer randomly selects a letter from the alphabet. Do you know how many letters are in the alphabet off the top of your head? Would you have to go like this? A, B, C, D, or just Google it? It's 26. There are 26 letters in the English alphabet. So how many different outcomes are possible? 26. I just told you. So you would say there are 26 things in the sample space. The sample space isn't the number 26, but the size of the sample space is 26. What is the probability that the computer selects the first letter of your first name? For me, that would be an R. That might be something different for you. But either way, that's one letter out of 26, whether it's an R or a G or an M or whatever, it's 1 out of 26. Assuming that this computer is not rigged to pick some letters more often than others, right? Assuming that it's truly randomly picking each one. And what is the probability that a computer selects a vowel? So I want you to think of our sample space here. Our sample space for this chance experiment would be every possible letter. So you would have to write the alphabet out, 26 letters, A, B, C, D, E, okay? And then it's asking you, what's the probability of pulling one of these 5, A, E, I, O, U? So it's 5 in our sample space out of a sample space of 26 things. Sounds like a 5 out of 26 chance to me. Let's move on. All right. Oh, the Earth moon weight one. Sometimes I mess this one up because I get it backwards. So it says E represents an Earth's weight. Sorry, see, now I can't even read it, let alone do it. E represents an object's weight on Earth, and M represents the same object's weight on the moon. So most people know this, but in case you haven't learned this yet, things weigh less on the moon because weight is a measure of gravity's pull on mass, and there's less gravity on the moon, so it's pulling less. In fact, it's about 1/6. The gravity on the moon is about 1/6 of the gravity on the Earth. And I believe, and I know there's a relationship between an object's gravity and its mass. So I believe that means the moon has about 1/6 the mass of the Earth, but I could be wrong about that. The relationship might not be proportional like that. So I don't know, feel free to correct me in class if I'm wrong on that. But either way, your moon weight is equal to 1/6 of your Earth weight. And now for some students, it looks a little weird because it's like, well, wait, why is the 1/6 with the E if it's the moon that is 1/6 of the Earth, right? You have to make sure you're reading it properly. Read it out loud to yourself this way, and hopefully it makes more sense. Your moon weight is equal to 1/6 your Earth weight. So even though the moon is the one that's 1/6, the 1/6 needs to sit with the E so they can multiply together. All right, so 4.1, what does 1/6 represent in this situation? Well, it's kind of like a constant of proportionality, right? If you think of this as y equals kx, the k in this case is the 1/6, but you could write something about that. I'd probably write an object's weight on the moon is 1/6 its, oops, nope, you don't want that parenthesis there. The parentheses means it's saying it is, so no parentheses, or no, sorry, no apostrophe, I mean to say no apostrophe. It's weight on the Earth. Okay, so if a person weighs 24 pounds on the moon, how many pounds would they weigh on Earth? Well, just reverse the relationship. If you weigh 1/6 as much on the moon as you do on the Earth, then turn it around logically. That means on the Earth, you weigh 6 times as much, right? So we could just do a 24 times 6 on that, please. You should get 100 something. 24 times 6. Okay, we are at the Explorer. You know the rule when it comes to the Explorer. You got to at least try it. It's okay if you can't. Sometimes these are tricky and they take you all night to try to figure out. And I don't want you banging your head against the wall. So see if you could try it. Notice that this thing over here is supposed to be a percent. This is supposed to be 0 point, whatever you put in here. And this one's also a percent. So like if you, and then these are fractions. And so if you make this like 1 over 0.4, right? 1/4. But then you make this 23. This would not work. This would be wrong because 1/4 is equal to 25%. And you can't put something lower, 23%, way over here in the likely zone compared to here. So whatever goes here should be really small, close to 0, because it should at least pretty closely mimic this. 0, 1/4, 1/2, 3/4, 1. So you want something close to 0 here, something close to a fourth here, something close to half. Like I might start by writing 0.5 in that box. Something close to 3/4 here, might not be exact. And then something close to 1 here, maybe 98%. I don't know. I don't know if that's right or not, but just try it. All right. See ya.